Hi, my name is Sejal Mistry, and today I'll be talking about mathematical modeling. So, mathematical modeling is a process that uses mathematics to represent, analyze, make predictions, or otherwise provide insight into real-world phenomena. This does not mean that we use problems that say, John paid $45 for 40 watermelons. How much was each watermelon? That's just unrealistic. We're talking about mathematics that are used in sciences, history, politics, health, fashion, and many other careers that our students are probably going into in the future. Now, why is this a problem? Well, model with mathematics is actually one of the 8 SMPs. Here's a description of what the standards of mathematical practice describe. Before entering this program, I would not have assumed that modeling with mathematics would be an SMP. I rarely use modeling in my mathematics classrooms up until AP Stats or Calculus, which most students do not even get the opportunity to take during their K through 12 learning. This leads to us thinking that teachers are actually shying away from mathematical modeling. This can be very hard for many teachers depending on the area they teach in and how many classes they have to teach. Usually teachers say that they do not have time. So gradual implementation of this can help teachers spread out what they're doing, so they can start with a project and then let students choose from different topics, and then a lot of teachers are scared because they are inexperienced. So one way to combat this is using your resources, such as other teachers, textbooks, online sources, research, and etc. So, modeling actually helps students see the value of mathematics, but teachers need to believe in the value of mathematics and build this connection between mathematics and the real world for us. So we have to provide tasks and demonstrate the use of mathematics in the real world, but this becomes a problem when teachers are not provided with the proper resources. Meyer actually took 2 textbooks that claimed that their tasks captured specific standards such as modeling, and only 83 of those tasks were labeled as modeling. So it's not just teachers, but textbook creators who spend months creating and revising tasks who overlook this SMP. So a case study was done between these 2 schools, and you can pause here if you want to look at it a little bit more. But School B used these little booklets that use techniques that were not being used in realistic problems or activities during their everyday lessons. So understanding the meaning of these techniques and their underlying processes and their application in the real world was missing. These textbooks did not give the students the opportunity to make the connections that would allow them to transfer their knowledge to real world situations. And then secondly, modeling actually helps create mathematical learners. So mathematics should always be questioned and explained thoroughly. It's the reason mathematics has evolved so much in history and is still evolving today. So in the same study as before, researchers actually found that most of the students in School A had more tendencies of a mathematical learner, such as breaking down the context, describing their thinking, and exploring mathematics of a task. So this is because School A was predisposed to challenge and explore the mathematics of the task due to prior practice. Then we talk about things such as mathematical literacy. So questions are not presented in real life as mathematics problems in mathematical language. So Kohler emphasizes this idea in her article, and she gave her students a task about US population size and 3 models that led to the same or different outcomes. And students were very fascinated with these contradictions and believed that discussing the models were actually worth their time. And this can be used in politics, medicine, world data. It's stuff that we see on the news that is not as realistic as we think. So this leads to realistic modeling. So who actually buys 40 watermelons? No one. So mathematics in the real world is not as clean as we think, but that doesn't mean that our textbooks and other resources can't be used. So learners can use the textbooks and stuff to question validity of our context and explore more about it. We will not end up with clean and clear numbers in the real world, but using some of these tasks allows students to build the necessary skills to build up to these real world solutions. So these are my references, and as a closing statement, I would just like to say that implementing these changes can be difficult in a mathematics classrooms. However, every topic, lesson, or unit does not need to involve mathematical modeling. We just want our students to know and understand why mathematics is important. So making it relevant to them, their future career, and the world around them through modeling can actually help make better mathematics learners in the classroom and in the real world. Anyway, thank you for listening. I hope you enjoyed my presentation.